Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today is the problem number 6, which is the last question. Now basically I'm trying to give different varieties of question in each and every problems. So today's topic is the basic of next videos, which is Laplace transform of periodic signals. Now, in today's question, the graph is simple one square wave. Now, if look at here, in this question, the graph is simple square wave which is available in between 0 to 2. Now, in next videos, that is, if the problem or numericals based on a graph which is a periodic, if we want to find out a Laplace transform periodic signal, which means we have such type of graphs, but it is a continuous, or you can see there is a continuous oscillations of such type of graphs. Now, whenever you want to find out a Laplace transform of such questions, then you should know how to find out the Laplace transform of first wave, which is important. Why the first part is important? We'll study this question in the next upcoming videos, which is based on the Laplace transform periodic signals. Now, in this question, just go through this question first. Today's question is problem number 6, which is the last question. Now, in this question, we have a simple square wave which is available in between 0 to 2, and it changes its amplitude after in some interval, that is in between 0 to 1, the amplitude is 1, but from 1 to 2, the amplitude of this wave is -1. And we have to find out the Laplace transform of such type of waves. You can say that it is a type of AC wave where the amplitude is continuously changing and it is available on both the sides. That is, we have a positive amplitude also as well as negative amplitude also. Now, this type of questions are much more important from exam point of view, because in exams, most of the times they ask the questions related to the periodic signals. But if a question is related to this such type of questions, then it is easy to find out the Laplace transform, because what we have to do, we have to find out, or we have to express this graph only in equations. Now, once you know, or once you get the idea how to represent this graph into equation, then it is easy to obtain the Laplace transform using the equation of that graph. So let's move on to equation. We'll find out first of all the equation of this graph, and then we'll move on to its Laplace transform. So first of all, the graph. This is the x of t that I have plotted over here. Now, first important, in between 0 to 1, this x of t is having amplitude 1. So what I'm going to do, I'm going to write x of t having amplitude 1, but where in between 0 to 1. Now, look at here. In between 1 to 2, its amplitude is changed completely. Now it is -1. So I'll write here -1, but where we have, when we have time period or the region 1 to 2. In region 0 to 1, this x of t is having amplitude 1. That's what I have written over here. In between 0 to 1, we have amplitude 1. And then in between 1 to 2, we have amplitude -1, which is over here, mentioned over here. Now, once you get this idea, what we are going to do, I'm going to apply Laplace transform, but much more important is x of t is having amplitude 1 in between 0 to 1, whereas it is having amplitude -1, but in between 1 to 2. So first of all, we will apply the definition of Laplace transform, and according to the definition, what we are going to write, a Laplace transform of any time signal x of t is represented in Laplace domain and mentioned by x of s, or you can say represented by x of s, and the definition of Laplace transform is -infinity to infinity x of t e to the power -st dt. Means we are going to first of all find out the product, and then we'll integrate over the range from -infinity to infinity with respect to time t. Now I'll substitute the values of x of t as well as the ranges, that is 0 to 1 I'm going to substitute over here, where x of t value is 1, and plus the product, and then plus the next interval, that is 1 to 2, having x of t value -1, and which we multiply with e to the power -st. Now look at here. I have substituted the values of x of t. Here x of t value is 1 when its range is 0 to 1, and then x of t value was minus 1 when the range is 1 to 2. Now simply just look at here. We know that integration, that first of all 1 into e to the power minus st is e to the power minus st. Whereas in second part I will take minus sign common or outside this bracket. So what you will get, 1 into e to the power minus st, and this will remains as it is, that is e to the power minus st will be integrated. So first bracket we have 0 to 1, which is integration limit, and we are going to integrate only e to the power minus st with respect to time dt. And in second bracket what you have, in second integration we have time limit 1 to 2, and what we are going to do, e to the power minus st dt will be integrated. I'll take this minus sign outside and then I'll integrate. So first of all, integration of e to the power minus st is e to the power minus st upon minus s, because the coefficient of t will be in the denominator. I'm going to write in denominator, and the time limit is 0 to 1. Minus sign I'm going to write it first, because this minus sign I have taken outside, and the integration of minus st is again e to the power minus st upon minus s, and the time limit is from 1 to 2. Now substitute upper limit and lower limit in both the parts. So first part we have e to the power minus s, 1 I have substituted first, and then second part is here the t value is 0. So if I substitute t value over here, the e to the power 0 is always 1 whole divided by minus s. This is my first part minus. Now we'll solve this part. I'll substitute upper limit first. So we have e to the power minus 2s minus, I'll substitute my lower limit e to the power minus s and whole divided by minus s. Now what I'm going to do, I'm going to equate, or I'm going to take minus 1 by s common from both this term. Now I have taken 1 by s minus 1 by s common from both the brackets. Now what you will get, in first bracket we have e to the power minus s minus 1, and minus in second bracket we have e to the power minus 2s minus e to the power minus s. Now if I take this minus sign inside, or if we multiply this minus sign inside, what you will get, 1 minus 1 by s, in bracket we have, what you will get, e to the power minus s minus 1 minus e to the power minus 2s, minus minus become plus, so we have e to the power minus s. Now multiply this minus sign inside, but first of all we'll take some common parts, or we'll equate some common parts. So look at it, e to the power minus s, e to the power minus s is common, so I'm going to write minus 1 by s into bracket twice of e to the power minus s minus 1 minus e to the power minus 2s. Now I'll multiply minus sign inside this bracket, so what you will get, minus 2 e to the power minus s, this one become plus 1, this next part will also become plus e to the power minus 2s, and we have whole divided by s. And this is the Laplace transform of a simple single square wave. This is how we are going to proceed. Now the much more important, why I said the first part of this, if we have oscillations, a number of oscillations are given in question, then as I told you in while proving the periodicity property of using a Laplace transform, now in that part I have mentioned the x1 of s. The x1 of s is if we have number of oscillations in a graph, then you can say that the systems or the signals repeats of itself after given each an interval of time. Means what, if we find out the Laplace transform first part, that is only a first time period, then the same amount will be delayed with given time period. The Laplace transform will remain same, only the delayed part will be multiplied with each and every particle. So why I said first part is important, because in this question, suppose if we have a number of square waves, then you should know how to find out the Laplace transform first part. But before finding the Laplace transform, you should know how to write the equation. So much more important is writing equation of given graph. And if you know that part, then you can obtain the Laplace transform of any type of graph. So in next further videos, we will solve the problem based on the periodicity of signals. So thank you for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda for further more videos. Thank you so much.